Earth's atmosphere and wind flow. We believe Earth is the only planet in the solar system with an atmosphere that sustains life. Earth's atmosphere is a blanket of gases that extends about 300 miles above its surface. The atmosphere thins out in each higher layer until the gases dissipate in space. There is no distinct boundary between the atmosphere and space. There is an imaginary dividing line about 62 miles or 100 kilometers from the surface. It is called the Kármán line and is usually where scientists say atmosphere meets outer space. Earth's atmosphere is divided into 5 main layers. Listed from the ground up, these are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere is the layer closest to Earth's surface. It is 4 to 12 miles thick and contains half of Earth's atmosphere. Air is warmer near the ground and gets colder higher up. Nearly all of the water vapor and dust in the atmosphere are in this layer. That is why clouds are found here. The stratosphere is the second layer. It starts above the troposphere and ends about 31 miles above ground. Ozone is abundant here, and it heats the atmosphere while also absorbing harmful radiation from the sun. The air here is very dry and about 1,000 times thinner than it is at sea level. The mesosphere starts at 31 miles and extends to 53 miles high. The top of the mesosphere, called the mesopause, is the coldest part of Earth's atmosphere. Its temperature is, on average, about -130 degrees Fahrenheit. The thermosphere extends from about 56 miles to between 310 and 620 miles above Earth. Temperatures can get up to 2,700 degrees Fahrenheit at this altitude. The thermosphere is considered part of Earth's atmosphere, but the air density is so low that most of this layer is what is normally thought of as outer space. The exosphere, the highest layer, is extremely thin and is where the atmosphere merges into outer space. It is composed of very widely dispersed particles of hydrogen and helium. According to NASA, Earth's atmosphere is composed of 78% nitrogen, 21% oxygen, 0.93% argon, and 0.04% carbon dioxide, plus water vapor and trace amounts of neon, helium, methane, krypton, and hydrogen. Let's think about the weight of the book exerting pressure on the table, where pressure is defined in this way. Pressure equals force divided by area. In this case, force is just the weight of the book, area is the area over which the book is in contact with the table, and pressure is the weight divided by the area of contact. Pressure is the ratio of force to area. Pressure is defined as the force per unit area. Since the units of force are newtons, and the units of area are square meters, the units of pressure are newtons per square meter. Here, the relative size of the atmosphere is increased for clarity. Earth's atmosphere has mass, which is attracted to Earth's center, like any other mass near Earth. It pushes down, creating a pressure on everything on the surface of Earth. The mass of air pushing down on every square meter of the surface of Earth is more than 10,000 kilograms. The weight of that air is about 101,000 newtons, or 22,000 pounds per square meter. So the resulting pressure is 101,000 newtons per square meter. The barometer is a device for measuring atmospheric pressure. A tube filled with liquid is turned upside down in a container of the same liquid. The atmosphere pushes down on the surface of the liquid in the container. Normal atmospheric pressure at sea level is referred to as standard pressure. It is equal to all of the values below. Standard air pressure is just the average value for Earth at sea level. Local air pressure can vary dramatically. In general, local air pressure will vary with the temperature of the air. Higher temperature air has lower density and, therefore, less weight, so results in lower air pressure at the surface. Cooler and therefore denser air has more weight, making local air pressure higher. Air is a fluid. Fluids move from areas of high pressure to areas of low pressure. Warm air has a lower pressure because it is less dense than cold air. When cold air is separated from warm air, air will flow from the cold region with high pressure to the warm region with low pressure. This airflow is called wind. As the beach warms during the day, the air above it warms and becomes less dense compared to the air above the water. That results in lower air pressure above the land than above the water. A wind blows from high to low pressure, from sea to land, making the warmer air above the beach rise and the cooler air above the sea sink. As the beach cools during the night, the air above it cools and becomes less dense compared to the air above the water. That results in higher air pressure above the land than above the water. A wind blows from high to low pressure, from land to sea, making the warmer air above the sea rise and the cooler air above the land sink.